Thank you for stopping by. You are welcome to my channel. In today's class, we are going to look at calculations on circular motion. We're going to look at calculation on circular motion. If you are new to this channel, please consider subscribing for more interesting tutorials. So, I have done a video on explanation of circular motion, centripetal force, centripetal acceleration with lots of graphics and short clips for a detailed understanding. So herein we discuss a lot involving the formulas, derivation of formulas, and all the formulas that we need to solve problems on circular motion. So in today's class, we are going to solve one or two questions. I listed like 5 important questions, of which, if understood, you will have no problems on circular motion again. So let's start. The first question says, calculate the tangential velocity a stone will move off a cycle of radius 4 meters, moving on circular speed of 2 rads per second if the string eventually cuts. So this is a scenario we are talking about here. If you look at this movement of the object attached with the string, you see the moment it got cut off from here with these scissors, the direction of what? Of the object is tangent, right? Is tangent. It will go off in a linear direction due to the tangential velocity. If assuming it cut off in this direction, at this point, the direction would have been like this, tend to move in the straight line. Assuming it cut off here, the direction will be like this. It tends to move in a straight line, and due to the force of gravity, it will definitely go down like this. So these are known as tangential velocity. So the reason why the body we kept on in a circular motion is as a result of the centripetal force, which is the inward force that keeps an object in a circular path. Solution. Given that the radius is given, so any time you are dealing with circular motion and the value is in meter or centimeter, you should know that is the radius. Radius is given r, is given to be 4 meters, and angular speed omega, is given to be 2 rad per second. Are we clear? And the question says you should find the tangential velocity, which is v. So we are looking for tangential velocity. So recall that we have v is equal to omega r. So the next thing is for me to substitute the value of omega, which is 2 multiplied by the radius 4. That will give me 8 meters per second. So the tangential velocity with which this object will move, if eventually cut off the circular path, is it will move with 8 meters per second. I hope this is clear. So take note of what? Of this formula. So that is number one. It's as simple as this. Number two, say a ball of mass 5 kg is tied to a string and whirled in a circular path of radius 1 meter with a uniform speed of 20 meters per second. Calculate the centripetal acceleration and the corresponding centripetal force. So your centripetal acceleration is the acceleration of an object performing circular motion, and it is always directed inward. Same goes to the centripetal force. It is an inward directed force that kept an object moving in a circular path. So this is the scenario that we have here. So this object is being whirled in a circular path, right? And the length of the string from here to this place, assuming here the axis, the center of rotation, is termed as the radius. So the length of this is termed as the radius, and the speed with which it moves, the uniform circular speed, which is termed as v, you can also call it as tangential velocity or tangential speed. In that case, it's given to be 20 meters per second. Then the mass of what? Of this ball is given to be 5 kilograms. So, solution. You have the following. The mass, M, is given to be 5 kg. And you have the radius, R, is given to be 1 meter. You have the uniform speed, V, is given to be 20 meters per second. The question is asking you to calculate centripetal acceleration. I use A, subscript C, I don't know it, question mark, and the corresponding centripetal force, I use F, subscript C, C. So it's unknown. So recall this formula as well, that centripetal acceleration is equal to V square all over R. It's as simple as this. So that will be equal to V is 20, then you square it all over what? What is R, which is 1. That will give us 20 square, that will give us 400. Yes. Over 1, that is still the same thing. That is 400 meter per second square, the unit of acceleration. Now, the next thing is centripetal force. Centripetal force, Fc, is given to be equal to mv square all over R. So in exam, or probably objective, all you need to do is just multiply the mass by the acceleration. That is all. That will give you your answer in a snappy way in case it is objective. Is that clear? So the next thing is mass is given to be 5. I don't want to stress myself much. I've already gotten my acceleration from here. I'll just multiply together to give the final answer, which is 2000 Newton. That is all about this question. Now, the next question says, a car of mass 500 kg moves with a velocity of 15 meters per second around a curved path. If the force acting upon the car is 300 Newton, calculate the radius of the curved path and the acceleration of the car. Okay, looking at this scenario, the car moving around this curved path is able to do that because of the influence of the centripetal force, which is provided by the frictional force between the wheel of the car and the road. The force acting upon the car is nothing but what? But the centripetal force, which is provided by the frictional force between the wheel of the car and the road. Are we clear? So, as usual, so the mass is given to be, M is given to be 500 kilogram, and the velocity V is 15 meter per second. If the force acting upon the car, I have already explained that the centripetal force is equal to 300 Newton. Calculate the radius. I'm looking for the radius R and the acceleration of the car, which is the same thing as the centripetal acceleration of the car. I don't know. But recall the formula that we have F is equal to mv square all over R. So in this case, I have F, which is 300 Newton. I have mass, 500 kg. I have velocity, 50 meters per second. So I can find what? Radius. In that case, I'll make radius the subject of the formula. By the time I cross multiply, I have R multiplied by F is equal to mv square. Then divide both sides by F. I have R is equal to mv square all over F. Then the next thing is to substitute the value of what? Of mass, V, and F. Mass is 500. V is 15. 15 squared all over what? R, which is 300. So let's say this 20, we cancel this 20. So I have it to be equal to 5 multiplied by 15 by 15. I just want to use this work. So I have 3 here. So 5, 3 here, 1, 3 in 15, I have 5. So the whole thing become 5 multiplied by 5 multiplied by 15. I have it to be 25 multiplied by 15, which is equal to 375 meter. So I have gotten my radius. The next question said I should look for the acceleration. To get the acceleration, recall again that we have A, acceleration is equal to V square all over R, which implies I'm going to have 15 squared all over R is 375. So I'm going to have 15 squared 225 all divided by 375. Hence, acceleration, centripetal acceleration is equal to 0.6 meter per second squared. So make sure you take note of these formulas. They are very, very important. Take note of these formulas. F is equal to mv squared. Take note of this formula. V squared all over R. So that is that about it, number 3. Let's move to number 4. Question number 4 says, calculate the angular speed of a wheel making 120 revolutions per minute. So here, as usual, we have solution. Given that the number of revolution is equal to 120 rev per minute, that is in 1 minute. Here you are given that the time taken is 1 minute, which is equivalent to what? 60 seconds. So what are we looking for in this case? We are looking for angular speed. I believe you know our angular speed is omega, which we are looking for. So recall that we have 1 revolution is equivalent to 360 degrees, which is equal to 2 pi radian or rad. So angular speed is measured in what? Rad per second. So if we have 1 rev is equal to 2 pi rad, then 120 revolution will be equal to 120 times 2, which will give us 240 rad. I hope this is clear. So having gotten this, recall we have the formula that omega is equal to angular displacement all over time. So your angular displacement theta is now equal to 240 rad. So from this formula, I'm going to have 240 rad all over 60 seconds. 0, cancel this 0. I'll be left with what? 24 rad all over 6 seconds. 6 in 6, 1. 6 in 24, I have 4. So omega will become 4 rad per second. So the answer is 4 rad per second. I hope this is clear. The next one and the final question is this. The question says, the Earth's orbit around the sun has a radius of 1.5 times 10 raised to the power 11 meter. Calculate 1, the angular velocity, 2, linear velocity of the Earth during its revolution. This question is not direct. You can see you are not even given the period, but by the moment you hear the word revolution, what should come to your mind is how long does it take, because a revolution simply means complete a cycle. How long does it take Earth to orbit the sun? So in that case, solution. I have the following data. I'm giving the radius to be equal to 1.5 times 10 raised to power minus 11 meter. That is all I'm giving. But it takes 1 year for the Earth to orbit the sun. So which means that the period here, we use capital letter T to represent period. We have discussed it in our previous video on the explanation of a circular motion, relationship between period, angular speed, and the rest of that, and frequency, etc. So that's to say that period is equal to 1 year. That is the time. So this 1 year in days is equivalent to 365 days. So I have to convert the whole of this into second. And to do that, to convert days into hours, I'll multiply it by what? By 24. Then to convert this one into second, hour to second, that is multiplied by 300 and 3,600. So I'll multiply the whole of this in together to convert a year into a second. That will give me 31,536,000 seconds. So I have my period. So having gotten my period, the angular speed, relationship between the angular velocity and the period, we have that omega is equal to 2 pi all over t, right? So that will be equal to 2 multiplied by pi, approximately is taken to be 3.142 all over the period, which is 315,360,000. So that will be equal to, if I say 2 by 3.142, I have 6.284 all over 315,360,000. So that will be equal to, by the time I divide this by 31,536,000, that will give me 1.992 times 10 raised to power minus 7. That is rad per second as the unit. So that is about the angular velocity. The second question says we should calculate the linear velocity. Now, the relationship between linear velocity and angular velocity is that the linear velocity is equal to omega r. Are we clear? So in that case, I've gotten my omega. So omega is 1.992 times 10 raised to power minus 7. And that of radius is given to be 1.5 times 10 raised to power 11. So this will be equal to 2.988 times 10 raised to power 4 meter per second. So that is how to approach this type of question.